Today we're talking about how to find the antiderivative of each of the 6 basic trig functions. So we already know the antiderivatives of 2 of our basic trig functions, the antiderivative of cosine of x and the antiderivative of sine of x. The antiderivative of cosine of x is positive sine of x plus c. The antiderivative of sine of x is negative cosine of x plus c. That's because if you take the derivative of sine, you get positive cosine. If you take the derivative of negative cosine, you get positive sine. Okay? It is frequent that kids get the signs mixed up, because it's backwards from taking the derivative of these things, which is exactly how I think of it. It is the opposite of taking the derivative of it, which makes sense because this is an antiderivative. So shouldn't it be the opposite sign of what you do when you're taking the derivative? That's one way to think about it. So method 1 of how to remember this is just to remember that it is an antiderivative. Okay? The derivative of sine of x is cosine of x, which means if you integrate cosine of x, you should get sine of x. The derivative of cosine of x is negative sine of x. So if you're integrating sine x, you should get a negative cosine of x, plus c on both of those, of course. Alrighty? That's one way to think of it. Another way to think of it: if you're integrating cosine, keep the sine and write sine. Integrating cosine, keep the sine, write sine. It's a little phrase that I do like. I do like that one too. Okay? And then we know it's the opposite for sine. So if you're integrating sine, you change the sign. All right? Another method that some students like. This method works well if you remember this setup. Cosine is always on the x-axis because cosine is related to the x-axis, right? Put the positive on the positive x-axis, put the negative on the negative x-axis. The negative side, I should say. Sine is on the y-axis, positive is up, negative is down. Okay? And then you just need to remember that to find the derivative, you go clockwise. Go clockwise. So if I want the derivative of sine, I go clockwise, and it is positive cosine. Clockwise is the derivative. Okay? So if I'm taking the derivative of cosine, it is negative sine. If I'm taking the derivative of negative sine, it is negative cosine. If I'm taking the derivative of negative cosine, it is positive sine. So derivative, you go clockwise. Antiderivative. Antiderivative, let me get a different color here. I don't know what color. Okay. Antiderivative, you're going to go the other direction. So you go counterclockwise. If I'm taking the antiderivative of sine, it is negative cosine. So this is the integrating way. Okay? If you're taking the antiderivative of cosine, it is sine, etc. Antiderivative of negative cosine is negative sine. Antiderivative of negative sine is positive cosine. So to me, that seems like a lot of work. A lot of work. Whereas to me, I prefer one of these 2 methods. But each year I have some students who like that. If it works for you, it works for you. I don't care how you remember it. I just need you to remember it. Okay? So find a method that works for you so that you can always get these 2 guys right there. Okay? All right. Seemed like a bit of time to spend on that, but maybe worth it. We will see. All right. Now let's look at the other four basic trig functions. How can we find their antiderivative? Well, what I'd like to do for tangent, I will begin with tangent. I'm going to think of tangent as sine x over cosine x. And now I can do a u sub on it. So I can let u be the entire bottom here. So u is the cosine of x. And du is negative sine x. The derivative of cosine is negative sine. So I do need a negative with the sign. So I'm going to pull out a negative on the outside so that they are the same. And now I have du on top. So I have du over u, right? So this is negative integral du over u, which is negative ln absolute value of u, but u was cosine of x, plus c, and we're done. However, we're not happy. I'm not happy because I know tangent isn't happy. Tangent likes secant, right? Did we get a secant? No, we did not. That's not good. Not to tangent, because it really likes secant. How can we force cosine to be a secant? What can we do with this log? I can bring this negative, the negative coefficient, and make it the power on the cosine, right? And now it's 1 over cosine, which is secant. So this is the same as positive ln absolute value of secant x. And now tangent is happy, secant is happy, we're all happy. And now we can memorize that. So we are going to memorize that the integral of tangent x is ln absolute value secant x. Now, would it be wrong to say that it is also equal to what we got first? Absolutely not, because these mean the same thing. These are the exact same curve, okay? So either way, I don't care, whichever way you like to think of it. If we have this memorized, which we will have that memorized, and this is the one that I memorize, okay? If I have that memorized, then I can get the antiderivative of cotangent. If the antiderivative of tangent is ln of secant, then the antiderivative of cotangent is negative ln of cosecant plus c. Alrighty? So I don't memorize that. I memorize this one, and then I get to that one when I need it. Okay? Alrighty. Secant. The antiderivative of secant. Well, that is, the secant is 1 over cosine. But we cannot change, we can't, if we did that, if I wrote this as, get a little piece of scratch paper here, if I said that that's the same thing as 1 over cosine, can we do a u sub on that? Can we let u be cosine like we did for tangent above? U would be cosine of x. Du is negative sine of x, dx. Did Santa leave us a sine of x? No, he did not. So we cannot do that u sub. It does not work that way. Okay, so instead, I'm going to do a little trick. I am going to multiply top and bottom here, not by sign, by secant x plus tangent x. I'm multiplying top and bottom by that. So I'm really multiplying by 1, so I'm not changing the value, I'm just multiplying by 1. And my integral is now secant x times secant x plus tangent x divided by secant x plus tangent x dx, which is, if I distribute the secant x through the parentheses here, I distribute this, I'm going to get secant squared plus secant tangent, right? I'm going to write the secant x tangent x first and the secant squared x second. And now I'm going to do a u sub. I'm going to let u be the entire denominator. So u is equal to secant x plus tangent x, and what is du? What's the derivative of secant? Secant tangent. Plus, what's the derivative of tangent? Secant squared. Dx. Yeah? So on top now is exactly du. Don't have to multiply by anything. It's just the integral of du over u, which is ln absolute value of u. But what was u? U was secant x plus tangent x. So notice something about this. We were finding the integral, the antiderivative of secant x, right? And we found out it was equal to this. Is secant happy? Absolutely it is, because secant is self-centered and it comes first, right? And then its friend comes along. So secant x plus tangent x in the ln. So we need to memorize that one, because if we get that memorized, this guy over here is easy. Negative ln absolute value, replace secant with cosecant, replace tangent with cotangent. And we got it. Okay? So, let's recap all of the ones that we need to have memorized here. Okay, and you must memorize all of these, just as you did the 6 basic trig derivatives. Okay, so what is the antiderivative of cosine? Integrating cosine, keep the sign, write sine. Antiderivative of sine is negative cosine. What function's derivative is secant squared x? The derivative of tangent is secant squared x, which means the antiderivative of cosecant squared is negative cotangent x. What function's derivative is secant x tangent x? Secant x, which means the antiderivative of cosecant x cotangent x is negative cosecant x. So those were the ones we already should know. Now our new ones. The antiderivative of tangent x. Okay, here's my thought. Offhand, I don't have a memorized derivative of a function that will give me a plain tangent x. So I think this is one of the ln ones. ln absolute value of the friend of tangent is secant. And tangent is not self-centered. It does not need to be there. Then the antiderivative of cotangent. Negative ln, replace secant with cosecant. Antiderivative of secant. ln, I don't know a function whose derivative is secant, so it's one of the ln ones. ln absolute value, secant x plus tangent x plus c. Cosecant is similar to secant. So negative ln absolute value, replace secant with cosecant, replace tangent with cotangent, and we're done. Something important to notice here. None of these has a square in the antiderivative. I see squares a lot when I'm giving you guys a quiz. I'm going to be giving you guys a quiz on this. I see a lot of squares. No squares. None of the things I wrote has a square. And no products. No squares, no products. This is a plus. The only ones that are not a single thing are these two, and it's a plus between them. All right? So no squares, no products. I get that a lot. People like to take secant and tangent and multiply them together because that's what we do for the derivative. Don't do it for this. It's a plus. Alrighty? Okay, that's it.